would like to welcome everyone to another screencast of Mr. Klein Mathematics. Today we're going to talk about simple and complex areas on a grid. Before we start, I'd like to remind you of a couple things. First of all, vocabulary terms are in purple, and you can pause the video at any point to write notes, try examples, or to just think about what you are seeing. Now we're going to begin with what is called a coordinate plane, a fairly standard grid. And I'm sure everyone has seen one of these before, and you've probably seen some simple shapes drawn on here, and you're supposed to count the tiles to try to figure out exactly what the area is. And that's all we're going to be doing today. So let's look at the simplest possible shape that you can probably put on here, which would be a rectangle. Now, this is not hard, but there's one thing that might be a problem, and that is the paper that you have in front of you will have lines already printed on the sheet, and then you're trying to put some other lines on here with your pencil or pen, and sometimes they can kind of get a little blended together, and we call this visual clutter. And it doesn't do anything to make the problem easier. So I'm going to eliminate that visual clutter, and we're going to deal with just the dots on the corner. And the first thing you'll notice is that the figure really pops out. It's easier to see the rectangle. There's no confusion on where you drew it. We're still going to draw some lines in here with our pencil or pen to make it easier to count the tiles, but beyond that, this now becomes an extremely simple problem. And just counting across here, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tiles. So we say that the area of this particular shape, this rectangle, is 12 square units. About as easy as you can get. Well, let's look at a slightly more difficult example. And we'll draw that over here. And the first thing you'll notice is that this shape is not a simple rectangle. It's something a little bit more complicated than that. And that makes it harder. In fact, when we have a shape like this, we call it a complex figure. A complex figure is a geometric figure for which we do not have a formula. And essentially, to find the area, we divide this figure into simpler shapes, such as squares or tiles or rectangles, triangles, or whatever. In fact, we'll do that here. So we're also talking here about simple figures. A simple figure is a geometric figure for which we have a formula, such as a triangle or square, circle, rectangle, etc. So that's what we'll work on here. So we'll first draw our lines, so it's easier to count the tiles. And you'll notice a couple things. First of all, we could just count the tiles, and it's not that big of a deal, but sometimes these figures can get very complex. They can get very large. If you notice in the bottom section, there's kind of a big square there, and that square is 5 squares by 5 squares. Above that, there's another square that's 2 by 2, and then above that there is a rectangle that is 4 by 2. And we can use those 3 rectangles to make this a little simpler. The 5 by 5 section is actually 25 square units, 5 times 5. The one above that is 4, and the one above that is 8, 4 times 2. And that means that the area of the whole figure is simply the sum of those 3 numbers, which is 25 plus 4 plus 8, which is 37 square units. And that's all you have to do to find the area of a complex shape. So the vocabulary today was simple figures, which is a figure for which we do have a formula, and complex figures, which is a figure for which we don't have a formula, in which we have to break into smaller, simpler figures to find the area. And again, I'd like to thank everyone for listening and watching this screencast, and I hope everyone has